Review investigation 4A. So in this investigation, we model a very large or small figure with a figure that is a manageable size. For example, we sketched a rough map of your school on paper or things like that, and we examined what the scaled copies are. So the key question was, why is it important to know that the scale factor when reading a map, and what is a well-scaled drawing, and also how can you decide whether two rectangles are scaled copies of each other? So we started out with looking at the maps and everything, and scale factor, and then we learned the definition of scaled figure. Scaled figure is another way of saying new figures. So you have original figure and new figures, but instead of saying new figure, we say scaled figure now. Scaled figure could be either bigger or smaller by using the scale factor, but the shape has to be the same. So shapes are congruent. Or we shouldn't say congruent. Shapes are the same, because congruent means the same shape and size. Shapes are the same. And we use such number as 2.5 or 3 or 4, the number that is bigger than 1, to make it bigger, make original bigger. And also we use such number as 1/4 or 1/2 or 2/3, some number between 0 and 1 to make it smaller. We cannot use any negative numbers, but we can use any numbers, any positive rational numbers at this point, or we can use irrational numbers, but let's hold it for now. So how do we use the scale factor? We basically multiply. Multiply what, right? So let's say we have 2 by 3 rectangles, and let's scale that by the factor 4, for example. That means for each length you multiply by 4. So the height of the rectangle will be 2 times 4, which is 8, and the base or the length of the rectangle will be 3 times 4, which is 12. So that's how you use scale factor. And you can also use that for 3-dimensional. So let's say we have 1 by 1 by 1 cube, and let's scale it by half. That means you'll have half by half by half dimension of cube. We have also learned that by the dog picture in lesson 4.3 that what's well-scaled drawing. So we are convinced that scaled or well-scaled means proportional. So for example, if you look at the flat screen TV, it has to be 9 by 25, I believe. I could be wrong. If it's 9 inch by 25 inches, it's pretty small, but you can scale by factor 2, which will give you 18 by 50. That's going to be pretty big. Or you can use the factor of 2.5 to make it a little bigger, or 1.7 to a little bit smaller than this guy. So that's what it means, because you don't want to see ill proportional picture on your flat screen TV. You're going to be really mad if your favorite actor or actress stretched horizontally, for example. If your favorite actor looks like something like this, and you're going to be mad. Okay? So it has to be proportional. You cannot just stretch vertically or just horizontally. You're going to have to stretch everything proportionally. So that's what we learned in 4.3. And for 4, we did a little more little bit more mathematically. So we looked at the measurements. So for example, if you have 2 by 6 rectangle, and let's say we have 3 by 9, are they proportional, or are they scaled? So we're gonna compare the smaller one, small number to small number, and large number to large number in the figure. And the rule is you scaled by 1.5, and also 6 to 9 you multiply by 1.5. Therefore, you're using the scale factor, so you scaled vertically and horizontally with the same rates, in other words, so they are scaled. And finally, on lesson 4, we have learned the 2 methods to check to see if 2 triangles are scaled and the rectangles are scaled. So one way of finding out is that for 2 triangles, if corresponding angles are congruent, okay, then they are scaled. For rectangle, if you put smaller one inside, take a point and draw a line passing through the corresponding vertex. If those lines are concurrent and inside of the rectangle, then they are. Or in other words, if you slide that smaller rectangle to the left corner, like that, you move that, and then if you draw a diagonal, and if that top right vertex and of both smaller and big rectangles lay on the diagonal, then they are scaled rectangles. And you could actually use that for many other figures like that. They are scaled. Okay?